We are going to discuss a question, some root to leaf numbers. So in this question, if you will be given a tree like this, 1 2 3 4 5. So what you will normally be doing, what you will be thinking is 1 1 plus 2 is 3, and 3 plus 4 is 7. So 1 plus 2 plus 4 is equals to 7. So this is one of the path. This is another part. From root to leaf, it is 1 plus 2 plus 5 8, and this is another path. So 1 plus 3 is equals to 4. Now our answer should be 7 plus 8 plus 4, which is 12 19. So 19 should be our answer, but in this question in lead code they have asked something different. What they are saying is that you don't consider it as 7, but consider it as 124. This is 125, this is 13, and now you do sum of 124 plus 125 plus 13, and this will be my answer. This need to be returned. Okay, so you got the question right. So how we will be doing it? You can do it using pre-order, in-order, post-order, or level order traversal. So this solution I have written in level order traversal, since it don't require recursion call stack, but I will be explaining, I will just give you an intuition how to do it using pre-order. And similarly, you can solve it using in-order and post-order as well. So if you are given a node like this, 4 5, okay, and uh, so as soon as you get a new node, so you say that okay, first I will get this new node, I will add it to my string, then I will go to its left child, I will say okay, I will add 1 to it, so it becomes 2. Then I will call for its left child, so it will say 4, so it becomes 124. And in this recursion, uh, in the next statement I will be checking that is this node a leaf node. However, I will be checking it. I will say that if this node's left child is equals to null, and also its node's right child is equals to null, then in that case I can say that this 4 is a leaf node. And what I will be doing is I will be changing its this string 124 and adding it to my answer. So basically plus is equals to 124. Okay, then what I will be doing is when I go so this is a leaf node, right? So I will directly say okay, now time to return. Okay, now it will return. So when I go back again, so this two's left child, oh okay, before I go back, I will say that remove 4 and then go back. Okay, I will say remove 4 and then go back, so the string becomes 12 again. And then I will go to two's left child. When I go to 2's left child, so first statement of the new recursion call will say, hey, this is the new node, right? So I will say 1 2 and 5. Then I will check, okay, it's a leaf node. So first I will be writing that insert this value in my string. So 5 will be added. So 5 will be added to my string, whatever number it is. So the string becomes 125. The next statement will be check if it is leaf. If it is something leaf, so I will say okay, convert 125 this and add it to our sum. So it becomes 124 plus 125 basically. Okay, uh, and then what you have to do, you have to remove it. You have to remove 5. So again the string becomes 12, and then go back. So now you have 12. Now what you will be doing is, you will say, okay, two's left child is also done, two's right child is also done. So I will go to parent, but before going to the parent I will say that I will remove the 2. So only one is there, and then I will go to one's right child, which is 3. So the first statement which will be executing in the next recursion call will be adding of 3 to 1, so it becomes 13. And then I will check that, okay, 13, sorry, 3 is the leaf node. So uh, just what I need to do is convert 3 to a number, so 13. So it becomes 124 plus 125 plus 13. The number becomes 124 plus 125 plus 13. And then what I will be doing is removing 3, and then going back to the parent call. And then once left parent is also done, one left children are also done, one right children are also done. So I will say, okay, remove 1 to the string and then go back. So in your sum you have 124 plus 125 plus 13, and return the sum. So basically you can either make this int some variable outside, or you can, what you can do is to pass it by reference, as I have done, not here but in the previous questions I did, right, when I was storing, when I in the diameter question. But in this video, in this solution, I have done it using uh, level order traversal. So how we can do it using level order traversal? In the level order traversal, we have to store that node, obviously. But here I am storing the string. What is this string? This string is basically storing. This string is basically storing uh, the path. Okay, this string is basically storing the path, and this is node. What is this path? Root to node. This node, root to this node path I am storing in this string. Got it? So basically, if it's like 5 4, so if I am storing this node, so I will store it like what? When I am storing this node, when 2, when I am on 2, and I will be pushing these two nodes 5 and 4 in my queue. So I will be storing it like, okay, if 2's left is not null, which is actually not null, so I will be pushing it like 5 1 2 and 5. So in this pair I will be pushing it. Also I will check that 2's right is also not null, so I will be pushing it 4 and 124. Got it? So now let's see the solution. I think this is pretty much it for this video, I mean this solution. So basically normal level order reversal, we have done it many times. What I have done, a to string of the root value, then I am again doing the same things, extracting thing we have done. Then SSF means basically sum so far. In sum so far, uh, by this I refer the path. This basically refers the path. It was like 1 2 3 3 4 5. So I mean to say that this is SSF. Okay, 1 plus 2 plus 5 is SSF. Okay, so I am taking out SSF, which is 1 to 5. So I have taken out 1 to 5 here, and then I am checking that is the fifth node is the fifth node a leaf node? So it says yes, it's a leaf node. So what I will be doing it, adding this 125 to my sum. So adding 125 to my sum, and no need to check for the left children, right children, because since it was a leaf node, so I will be checking it. And then I've done continue, then it will be going to the next child, and same things will be happening again and again. So how I am adding children, I am adding children that like this. uh, Previous SSF means part till now, and adding this, the new children value. So the path becomes, so till here it was something 125, and if it had us children like for example 6, so 6 will be added to it, so it becomes 1256. If it had means if it was like this, 3 4 5 6, so the path will be like something like this, 125 plus 6. Okay, so I hope you understood the solution. You like, if you like the video, so please uh, share it with your friends. Make sure you press the like button and subscribe my channel. Thank you so much for watching, and I will see you in the next one.